like, a lot of people, I'm sure, say like you got to still be grounded in where you came from. Like there's still statistics out there. There's still like what I've seen sometimes is that it is so approachable. That is another double-edged sword, let's say. People are not testing as heavily as they used to. You don't have there's cross-validation is an established technique. So just kind of like if you're going to get started, even a new data scientist following along with some Medium articles or something like that can do the proper cross-validation because it's just so commonplace. You just import it, you run it, like everyone kind of knows what they're doing with a validation set and a test set, at least a little bit. It's the finer edges that I'm saying people have to kind of pay attention to. But now, because machine learning, like the Gen AI is so approachable, people kind of forget that. And they're just like, hey, I tried it on three things and it worked, so let's go to production. Because it feels like you can do that. The models are there, they're going to work just as well in your dev environment as your test environment, your production environment. But that doesn't, so people, I think maybe they don't realize they're probably cutting a lot of corners right now.
Hi, friends, and welcome to this exciting episode of Leading with Data, where we bring the perspective of top industry leaders for all of you. Today, we have Mark Landry on the show. So, Mark and I go a long way back. He's currently a director of data science and product at H2O.ai. And being a director of product at H2O.ai places him at the right spot in terms of what's happening in the domain, what are some of the developments expected in future. He has himself been a data scientist, a Kaggler. That's actually how I know him. So he was one of the most active members in analytics with their competitions when we launched our competitions. And he, at his peak, was ranked 33 Kaggle Grandmaster. So, in this discussion, we talked to Mark about his views, his journey, and how he sees industry shaping up in future. So, let's get started.
Mark, welcome to the show and looking forward to the discussion.
Thank you for having me. Yeah, welcome. I'm glad to be here.
Yeah. So, Mark, let me start with your journey into competitions and since then. So, how has been your journey? Uh, uh, what was the early days of those competitions, and then how that did that translate to your role currently at H2O.ai? So what has been your journey from your perspective?
Yeah, great question. So my journey is a little unique. Some people find it interesting. So when I went to school, I kind of wanted to do data mining at the time. Did undergraduate computer science, had one course in AI, and that was really it. And I started working doing reporting, analytics, and warehousing and things like that for about 7 years or so of my career. And I liked it. There's a lot of problem solving in there, and I think there's even some techniques and some methodology I took from that when I eventually got into data science, kind of where I wanted to go. So after about 7 years, I kind of realized, like, I'm doing this and I like it, but I wanted to do this AI stuff. And so so I just started kind of learning on the side, and it coincided in a weird way with having my my older son. So I just found myself helping him go to sleep at night, and with a lot of time on my hands, but I had to hold him and I couldn't actually work. So it was this weird thing, and after watching some sports for a while, I just started getting into like self-learning with just what was out there on YouTube. And I just stumbled on a really cool course that hit me at the right level. It wasn't too advanced. It wasn't even Andrew Ng's kind of course, which a lot of people took back in the day. And started getting into R and really seeing like it's really approachable with these scripting languages and stuff. I learned like Java and C++ early on and was doing SQL. So it was really cool to see how just easy it was to get started. And so I got a job in analytics, and then all these people started right when Kaggle was getting some promotions. And so I had some people saying, "Hey, that job you have, like, do you do these competitions?" And I was like, "No, I'm just learning what I'm doing." But after so many people asked, I finally just got into it, and I went to a meetup in Austin. And someone who was at the time, I think fourth or fifth in Kaggle, actually was there and made a comment, and that finally tipped me over to try it. And once I tried it, I was like, I think I could do this. Maybe in my first submission ever, I just remember was a CSV that I just did in SQL. It was a SQL group by statement. It was really simple, but it's just like, let me just see. And that was the cool part of Kaggle at that point. Like, it was really easy to get started, a low barrier. And so I was in the middle of the pack, and I was like, boy, that was easy. Like, what if I tried? And that was it. So once I started actually trying, I took to it pretty easily, and GBM was just getting popular. And so I think one thing that was advantageous for me specifically, I think like that decision tree mindset, I understood pretty well and what they could and couldn't see. And so, your feature engineering at that point kind of came natural to me at that point,
Mhm.
for whatever reason. And so then it just became about problem solving. And so it was just fun. And it's just, there's a lot of us like serial Kagglers. You just almost can't get enough of it for a while. And so I was just always in one for a while, but learning so much. And a lot of what I told people back then is just that I think like the diminishing returns curve like was always a little more on the upward. Like you didn't trail off as much, and like every time you did another competition, if you're looking at it the right way, there's always some new technique or little nuance.
Mhm.
And so what I realized at that point too was that like when you can do a competition in a 2-3 months or so, you can keep doing them. You can do multiple, and you're learning these little extra bits. But it's really sinking in because you're pouring so much of your energy and your mind into it that when you see something where like a median, just going from RMSE to MAE or something to optimize, and you realize how much a difference that is for your machine learning. What you need to do, different tricks and techniques. You need problems to kind of really for it to sink in rather than just reading in a book. Yeah, we can do this or something like that. So I think just that real world experience is just more of who I am. I'm not a great student necessarily, so this appealed to me for just like hands on. Let's go try it and really try to absorb everything there was. And to some extent, like, that was what I really, really liked about the analytics Vidhya hackathons is the early days there. Those were like 1 day, 2 day, like weekend
Yeah,
kind of competitions.
not
So it's
intense.
the same. Oh, it was so fun because you're in there quick. And I think there's a lot of times, that where in the work world, that's about all the time you have with a problem. You may even have a month-long project, but you're getting data, you're talking to people, and all that kind of stuff. And when you're actually hit the ground and model, you often don't have much more time than that. So, I like that hit the ground running and go quickly. And it was just really fun to see like what some techniques would be because, in Kaggle, like you're usually going to get like in the first 2-3 weeks or so, people are usually going to top out the leaderboard. Not always. But then they're just arguing over like small gains, and there's still a lot to be learned from there. But so I do like the short cycle ones even better. That was really fun. And yeah, I just kind of got like addicted to it. The gamification. I wasn't really a competitive person, but all of a sudden, when you get yourself on a leaderboard and people see what you're doing and all of that, it was fun. So yeah, it was just a lot of fun. And then it's just all sorts of good things happen out of it. The collaborations. I was just thinking before this, there was a time when I think, SRK, Rohan, and I were like 1, 2, and 4, like in
Mhm.
analytics video. I don't even
Mhm.
know who they were. I think I was the lower one of the three, but it was fun, and we would just chat, and we got to know each other, and it was fun to collaborate as well. And even now at H2O, like most of the time when I compete in Kaggle, I'm competing with people I know. I work with, like, hey, you guys want to do this one? And I like the kind of team aspect of all that. So I guess that's the journey, and I think there's a lot to take away from it. I think part of your question too is just the skills you learn from it. Um, I think that like starting fast at a problem and having a good read on it is important because again, you don't have that much time, and so the more experience you get in these competitions, more data sets. Just there's different nuances and everything, and a lot of times in the work world, you can be on a project for 6 months, 12 months, 24 months. And that might be the only problem you see. And some people get a little more than that, but for the most part, we're not getting a whole lot of like churn in a good way on our problems, and so that's something always interesting about the competitions is doing that. And I think just learning how to work with people and seeing different things that you learn quickly with the competitions, like how to spot and try to protect against overfitting. And it's so easy to do that in the work world where a lot of times people don't drag up a lot of data. You start with something really small. You might start with almost nothing and just some
Mhm.
synthetic data. That happens so many times. Different companies we work with, it's not exclusive to just any one company. This is very common. And so in Kaggle, if you really go for it, you always want to protect against, same with analytics video. Do you want to protect against the flop, what's the shakeup is really what it's called. And so, if you have you're in 10th place or something like that, you want to make sure you don't drop to 20th or 100th or 1,000th or something like that. And so spotting some of the nuances of the problem, these happen in the work world. There's a lot of people who look at that data set that they picked up and they split it random cross validation and they don't realize there's some nuances there. When they go put that in production, they've done something wrong. They've looked at all the data and then they don't know there's new products coming out that you can't have seen in the trained data. You got to be ready for that. And if you do some of these things wrong, so I think one of the big things that's a sustainable one forever. It's just good statistics, really. It goes back to, for far in advance of machine learning. But yeah, I think a lot of us, like, your day one is to get nicely calibrated and understand the problem, understand how the predictions are going to maybe differ from what you can see. Those are some important aspects that every one of those, I think, translates to the work world too. But it's hard. It's hard. Like, even knowing that, doing it for 100 competitions and plus, like, sometimes you get in those work world and you can feel yourself overfitting because, oh, I've got 30 results. What do I do with this? So it's tricky. It's a tough thing to overcome, but the competitions can help kind of base you, and you understand the importance. You got to do it right. You got to be careful in some of that stuff. So, but a lot of fun. It's really fun to do the competitions. It's fun to do it in real life too. I think that was interesting about Kaggle, just seeing like the skills you do get of jumping on different data sets, and just gives you this mindset of really just extracting stuff quickly out of a new data set. How do you look at it? How do you understand it? And I think maybe that's what comes back from like kind of my analytics basis and data mining, or warehousing and stuff like that. You're looking at data a different way maybe sometimes than some people do from a statistical aspect. But just exploring data and understanding it, and then kind of getting some ideas for how you might do it. In competition world, you want ideas to get better than whatever else is going to do a little bit. But in the work world, you want a good sense, like, what's the basics that gets me to a certain level, and what are some things I might explore to unlock like some big gains, not necessarily small ones, especially in the work world. You're not really caring about third decimal place most of the time. Some do, but most of the time you're not. So
Yeah. And
yeah, I guess that's my journey.
I think one interesting thing in your case was you could also take some of these learnings, and I think at that time you were building the Auto ML uh, product, so you could experiment those as part of how much is transferable from competitions to products. So can you share what were your learnings or findings in terms of uh, out of these competitions, what you could probably apply to a product like AutoML, or your work from there on?
Yeah, I think, so with these AutoML tools, we put a lot of effort into, particularly with driverless AI, which was almost, you could say, Kaggle inspired, competition inspired at the time, and almost still to this date. Like, target encoding is a really strong method of feature engineering, and it's not widely accepted. Like, you don't just pull out scikit-learn and do target encoding, and so that was powerful, and a lot of us kind of knew that that was one of the emerging techniques, and doing it safely and well. So it's easy to overfit when you
Yeah.
do that, and so that's like kind of a double-edged sword, I would say, a lot. So doing it carefully in the tool was interesting. So you had competition techniques getting into the tool from day one, really. And then my use of it in competitions, you're absolutely right. That I did use it for several competitions, because then it was really doing is putting myself in the mindset of our customers. So it was, when we slave over a problem, and you might grind out code for weeks and hours a night for weeks. This is typically what it takes to Kaggle gold medal, sort of kind of, it's can take a lot of time for the overwhelming majority of us. But that's not real life all the time for a lot of our customers. So the AutoML tools, especially, are supposed to be as simple as possible and strong and trusted. So all this overfitting, type of stuff has really gone into that product. So yeah, trying to see how well it does in the real world. Like, we used to test it a lot, and probably still do, but on old Kaggle competitions. And you could see, oh, it would, if it were only to do Porto again, it would do like top 10 or something like that. But you always want to be seeing what the next ones were. We knew that, we almost overfitting in a product sense, that what techniques worked for those old ones. And so yeah, just applying it and trying to see, like, what is it like to use as a customer? Like, is it really push button? What do I do? What do I need to do to encourage it? So sometimes when I was doing that, I was really just checking it out and also doing my own side by side. That was really fun when I did that, I think twice in a row, where I was doing my own and I was pushing the button over there and just looking at back and forth. And so, yeah, it was nice to see. I liked what I saw. I understood it. It was doing some interesting things and some peculiar things, and so that helps us get the product better. And some things, there's like, it's really onto this idea of what I'm really getting at, these interactions it's going for and stuff like that. I was highlighting things. So I think that for me, using in the competition space was really to just start to make sure that we were making this useful for our customers and their expectations, rather than pulling people who are going to generate thousands of lines of code, really, and just making sure like the best of those techniques works in this setting, but you have to know how to use it. So I was trying to simplify things. And it's just great to have new problems again. Like you don't get data too much to do these things over again in the real world. So I would say almost competitions are real world in that way. That's what I've always liked about them. I feel a lot of people are like, oh, that's not real world, and you do drag up data. Like a competition, they've handled a lot of the data science process for you. But as far as the data quality and the problem solving, picking metrics, and all of these kind of things, I've always found they are realistic and they really will help you. So yeah, I would encourage people to keep trying to do that. I suppose. But yeah, that was the emphasis for trying it in competitions, especially just to make sure our product is robust and is really working for people. So as advertised, I guess.
Yeah. And how has been this entire development in generative AI and LLM
Mhm.
for the last few years from your perspective, and then how are you seeing this space now?
Yeah, it feels crazy. It feels crazy. Again, I got into Kaggle and almost really data science machine learning when GBM was just getting popular. I mean, the
Mm,
algorithm goes back to the 90s and in its current form, early 2000s. So it wasn't new then. It was 2012, 2013. I don't even know. Um, but and we're still doing that now. You can look at current competitions; they're still just evolutions. We like GBM, XGBoost, CapBoost. They're great innovations on GBM, but it all really goes back to Ada Boost of the
mm,
90s.
mm,
Gen AI, wow, like that's just so different. And so we saw the predecessor, of course, like it didn't come out of nowhere. So we would see like image deep learning, finally hit in 2006 kind of era, and it's gotten more popular. And but what I think I've seen, like with H2O, we get the kind of cool sense of seeing different customers, and so you get into different enterprise environments again a little more than you would if you have a standard job.
mm,
And there's certainly people that were using image recognition and NLP data sets, like high-end NLP, over time, but a lot of people just kind of stayed away from it because it felt advanced, or you had trouble digging up targets, and we're still working in supervised learning. And so adoption was happening, but kind of like slow, especially compared to when ChatGPT really kind of broke it wide open. So, those of us like kind of paying attention saw it with GPT-2, I would say for me personally. But then when 3 and 4 came out and you just saw it actually hit like regular people on the street know what
yeah,
ChatGPT is now. Like it's just so different. And yes, of course, like everyone likes to point to like the Gartner hype curves and stuff like that, and this trough of disillusionment and everything. And it's going to happen for people that maybe got extra carried away or think it's just going to solve all problems. But honestly, I would say like if we had some nice way of tracking it, that it feels like the hype is warranted.
mm,
Like people are using it, and it's just like if you find where it's useful for you, it's not going to be useful everywhere. Like, be careful. Like, there's a lot of people. So I guess going back, it's been crazy to track the progress, and it felt like it was kind of fun to be working at H2O when this was. At the spring of last year, just felt like, oh my goodness, like papers are coming out every day. People are paying attention to Twitter instead
yeah,
of like waiting for a conference or something, because everything was releasing so fast. And there was a really cool moment. So at H2O, we're our best engineers are sitting on top of that, developing product. What can we do with this? What can we do? And making some really cool stuff that was absolute bleeding edge on like for the libraries, such that I just remember it was a really fun time when the Falcon model hit. And for open source, it's been a big deal for us. And so at the time, you had Llama and Alpaca and some other kind of stuff, Vicuña, and then Falcon hit, and it's like, whoa, this thing could be bigger. And but it was so new that some of the libraries didn't even work for it. So we had to wait for like bits and bytes, or maybe PEFT or something like that, to to fix some little bugs or some like to expand. And it was just this open source community, just like
mm, yeah,
every hour it was just happening, and like in a day or a day and a half or something like that, all of a sudden it was fixed and it's online and we can test it, and just like seeing the benchmarks, it was so the pace was so heavy at that time. And it
mm,
still is. It feels like it's slowed down
yeah,
maybe a little bit, but because you have some more like the big incumbents are there, but it still is happening all the time. Like the multimodals are coming out like every little bit. We're seeing like Meta's hitting the low end now, small large language models. Google's the
2.2,
405B. It's just so it's still the pace is still heavy, but it just felt so different, and it's so approachable. It's just you can just get after it with a prompt. Like it's
yeah,
really you're not sitting here trying to supervise. Can I get 100,000 targets to supervise a high end classifier, CNN or something like that, which can take quite a lot of work. This is just everyone can use it, and it's interesting. So this one feels very different to me, I mean, I've only been doing this, I guess, maybe altogether 20 years, not even. So maybe I can't say that too much, but for everything I've seen, this is so different. And it's interesting. It just changes things. It expands it for some people, but it also, like, a lot of people, I'm sure, say, like, you got to still be grounded in where you came from. Like, there's still statistics out there.
Mhm.
There's still, like, what I've seen sometimes is that it is so approachable. That is another double-edged sword, let's say. Um, People are not testing as heavily as they used to. You don't have these. There's, cross validation is an established technique. So just kind of like, if you're going to get started, even a new data scientist following along with some Medium articles or something like that can do the proper cross validation because it's just so commonplace. You just import it, you run it. Like, everyone kind of knows what they're doing with a validation set and a test set, at least a little bit. It's the finer edges that I'm saying people have to kind of pay attention to. But now, because machine learning, like the Gen AI is so approachable, people kind of forget that, and they're just like, hey, I tried it on three things and it worked, so let's go to production. Like, because it feels like you can do that. The models are there, they're going to work just as well in your dev environment as your test environment, your production environment. But that doesn't. So people, I think, maybe they don't realize they're probably cutting a lot of corners right now. So with that amazing progress and approachability, I think we're in a good way making it simpler to use. But we do have to be careful that I think when professionals do this, ideally, everyone screws up, but we have some sense of trying to ensure that our training set and our validation set, our test set are all in place, and that you've really thought hard about going to production. And I do think we have to kind of like worry about that a little bit, but it's a great problem to have because it is so approachable that we just have to kind of be careful and make sure that it works. I've got a use case right now that I'm working on with a client that every time we shift data around in this overall space, it feels like our answers are changing. So we got to be careful because we're drawing from a certain distribution, and unknowingly we've kind of biased it in a certain way. And then we draw from another part of the distribution and the shape is different. So same model, same prompts, acting very differently. So there's still some kind of statistical principles going on with all this stuff, but it's great that you can just get in there and go for it and go try. So very exciting times.
And for you, because as you mentioned, you had been following GPT-2 and earlier models. When did it strike you that, the scaling laws in this case are just tremendous? So when was that realization that, by just throwing more compute and more data, the models are actually becoming a lot more smarter, so to say?
Yeah, I don't have a great answer for this one because it was like sort of because at H2O we have so many Kaggle Grandmasters that it was actually when it hit me was when Chunming had put together some kind of slides to kind of walk everybody through like the state of the art, and he was doing a better job of tracking where the open source was and taking a lot of the projects. So ChatGPT was out at that point, so it's probably like that same kind of time frame, like very early 2023 maybe.
Mhm.
So ChatGPT was out like late 2022, it feels like, or at least blew up around then. And so, but when you saw the papers, and at the time you had some like a big science paper, like there was a little bit of noise because probably some of the people weren't executing quite the same. But yeah, so once you really saw that, and if you could take out the couple outliers, like, okay, something's off with this one, but generally speaking, you could see that curve. So probably about that time, it seemed evident. And then also from then, you kind of take that theory or the principle in your mind, and you see that it is starting to be true. Is you just really see that bigger is better, unfortunately. But there's still some cool techniques, right? And that's why at H2O, like our foundational models, the DNU team, it's just awesome to see like there's just like some excellent Kagglers, so like just a different level from me. It's just like they're amazing. And they took all that the knowledge is out there and said, it isn't always just bigger and better. Like the techniques are important. And so what they had done with Danube was just really see all the best techniques at that time and be able to stretch that and get more out of it. So get a small language model, which isn't so small if we were going to go back 5 years, but we were talking at this time 2 billion parameters to behave like a 7B or even really 30B models, so 30 billion type models, and you could do that. So the techniques still mattered. The scaling laws are still there, really. So if you have good techniques, bigger is generally better. But there's still always things that the people that put the budget in there and just tried something, there's some ideas that where you can still mess it up a little bit. But you could see if you plotted everything that that x-axis of the billions of parameters is strong. So it's interesting to know where that's going to go. I think all of us are sort of rooting for something like a state space model, Mamba, or something like that to win out, so we can sort of get the computes down. It's not showing
Yeah.
up so far. We're still on autoregressive land. That would be nice, but Yeah, there's no denying it. It's tough to think of. It's amazing to think that we're really just dealing with next token and probabilities across. It's just like, and this works. This works makes some really. It feels like it's reasoning. We know it's not, but we feel like, gosh, that's really smart. And it's just next token probability. It's amazing what can be done there. So you like to kind of like intuitively move through models. That's my kind of favorite way to do competitions, is just start and look at data from a really primitive sense and just really get an idea of where the strong features are. But you can't pretend that it's not easy to intuit your way through how a 400 billion model really works and how it can remember that stuff. I mean, how it works is actually kind of, I wouldn't say simple, but you can follow that. But it's just amazing that putting this together leads to like the outcomes that we can see. So yeah.
Yeah. And so I think there are, two products or areas which where at least I am aware about, where H2O has kind of really been at the forefront. One is, Document AI, and the other one is H2O's own LLM, and then, some of the work which you mentioned. So just want to,
Yeah,
let's say, go deeper on each of these. So uh,
sure.
let's maybe start with Document AI first. Uh, so today, with so much happening on LLMs, and again smaller models is one interesting area. But let's say I am a developer who is trying to build a solution based on Document AI. So I have, let's say, a lot of financial documents. I want to extract information out of it. What is the, let's say, most accurate way? What is the most economical way? And what are some of the practices in this landscape? So how should I be thinking, assuming I don't know, and I'm new to this space?
Yeah, well, your question shows, that's a perfect question, because you nailed it right there. Especially where we are with generative AI, you're like, what's the most accurate way to do it? What's the most economical way to do it? So, yeah, that's definitely what we want to present. And so, this product goes back with like a tight collaboration with the customer when we sort of assumed that, like, 2018-ish kind of time frame, that you would have things out of the box that could just do an invoice or something like that, or just understand an invoice and everything you wanted to know, because it's kind of a common problem to do that. So, old school automation's been doing these kind of things with templates and stuff like that. And so we were kind of curious to see what to do. And we started attacking it when we realized it wasn't. We started attacking it with just a basic CNN, and that was not really a great idea. So, but you had models come in where, at the time it was a mix of CNN and some regular machine learning and OCR and all these kind of techniques going in. But you saw like what we've based our solution on. You can see like transformers models starting in specific to documents, and so the position of your tokens was interesting. So you can still do it like right now with transformers, like Debrita V3 is kind of your strongest NLP model, short of LLMs at this point, and has been for a couple of years, I guess. And so it'll just see the text left to right, top down, let's say. And but a lot of documents are laid out in different ways. So the orientation of the documents will start to tell you what's interesting and how people lay it out. They lay out on key value pairs usually sometimes, and they're very terse sometimes. There's not a sentence saying the order number is. Like sometimes it could just be order no, and then actually it might be below it, or it might even be in a different part. But we as humans just pick that up like really, really easily. So, but the model started understanding that visual perspective, or just the orientation, the space that it was in, and so we were using models that started to get smart. It's like one of these moments where I remember where I was. I was in a weird hotel when I was looking, finally analyzing the results of us using the new tools as they were coming in there. This was LLM at the time, and just like, wow, this is getting it. It was solving a lot of the problems we had from trying inferior techniques, and so that we found that was finally repeatable. And so we had 3 use cases in a row where we were putting a huge solution that where we plugged it in at the last minute, it replaced another technology, and it worked. And then the next time we kind of refactored it to make it more condensed, and we were able to turn around that use case quickly. And then the third time, even same thing, and that use case was someone who didn't even know what we were doing as much was able to turn around in like a couple of weeks. It's like, wait, we have something here. That led to the H2O product, but this is all pre-LLM, and so the basics of how that one works is OCR into a model that takes the coordinates and the natural language processing, so the tokens, and where it's a transformer, so it works very similar to what we have today, bidirectional. But and that's a good way of extracting things. So those models would actually train pretty quickly. So they were pre-trained for that. So it understood documents sitting on top of some big academic data sets. So we would show people that, like, sometimes if you just annotated like 25 documents, you can get some pretty compelling results like right away. And that's not too hard to get 25 labels for things. At the time, it's kind of intensive. You're boxing things up. You're having to teach it really specifically what it is, and a little bit of like non-intuitive data science where you might have to teach the model that the customer name is in all the places it is, even though a person extracting the document just cares about it once, and that there's some unfun ramifications of that. But building a product to help people work through that. Now, Gen AI comes along, and it's no surprise that you can just feed stuff in and it just knows stuff. It's seen so many in its training set. It understands, even like they're still not. You have multimodals now that can see, but really Gen AI has been good. If you just drop the text in, they can do a really good job on making, almost reconstructing what that document probably looked like when it was original, so that you can even see things where your tokens are way out of place, but they understand like this probably went to that. And so Gen AI was something where we've had to kind of innovate. So the product has been out there for several years, but with Gen AI, it makes it more approachable. These are heavier models, and so that's like your question was, what's the most economical way to do that? So we're still looking like there are some problems where basic OCR and either a small language model or even like yesteryear's small language model, like a more BERT style model, can still have a place because you can score on CPUs and some different things. But as the models get better and smaller, and we get better at finding small language models. So I think we're still exploring, trying to make sure we have the right fit. And really, for us, it's just kind of knowing the answers a little bit. So what you find is a lot of people in the document AI space that's not what they're doing all the time. They just have a problem. It's like, hey, we want to solve this, and we don't really want to think about it, or they do want to think about it, and they just don't really know. Or do I explore all these techniques? It can be expensive to try everything that's out there. And so what we just want to have a say is, okay, for this use case, which one is the best for you? For something simple, we may still see that the transformers, they're all transformers, but the BERT style models, dBERTA and LLM, can still maybe be a good way to do it. And especially on a budget, it can scale nicely and easily in Kubernetes horizontal scaling, but almost any of these things can be done with the LLMs as well. So certainly our research has led us to modernizing with LLMs using techniques like prompt tuning, not a well-known technique out there. So in between just zero shot, just prompting, and fine tuning, where you do still, even in LLMs, you usually need thousands of examples to get a good product at the end of the day. Prompt tuning is interesting because it's just tuning the embedding layer, and so you're really steering it towards exactly what you want. So it's an interesting way to get something specific to teach the LLM. They train quicker, so you can actually still work with these sound of like 10 on an easy document, 100 or something like that with a harder one, teach you what you want. So just knowing the breadth of techniques that are out there, that's led us to really explore. So then some of the times it's always been kind of frustrating with document AI is when you have your OCR locked in. Your all OCR is going to be pretty much like your weights are frozen, and the OCR is just doing its job out there, and it means you kind of can't teach it, you can't shape it towards a new data set, which might have some weird, that would look like augmentations to us. But we just dealt with a customer use case that even in 2022, 2023, they had a scanner out there that was just, the quality was really bad, really consistent, but it was just surprising. It looked like it was 20 years old, but it was a modern thing coming in, and the OCR was really struggling with that. And so I think what's exciting, and there's predecessors to the LLMs when you see like models like Donut and Pix Destruct and things like that, but that can actually, you can train them a little more easily to actually see the image and adapt without really looking at it as just a CNN or something of that shape. And so seeing the fusion together is where we're kind of exploring with multimodals and really taking our family of Danube models and plugging an image transformer, like these VITs, vision transformers, are not super new, but like the idea of a multimodal, really, if you're getting started, is to take an LLM and a vision transformer, and then you're just training the connection there and getting them to learn how to work together. So you're using kind of tokens of the natural language, tokens also of the image portion, and getting them to answer questions together. And so that's where we've been exploring. And so that's a pretty exciting space, I guess, for us, because it feels like that's going to unlock sort of the higher end. But it is almost like, if I had a diagram, really, like it feels like your question is interesting, because I do feel it's still use case to use case, you may get a different answer. So if you want the most accurate thing, it's probably going to be a heavy duty multimodal at this point. Maybe if you really want the heaviest accuracy, you probably train it yourself a little bit too. It just depends. Like, no, try it, see what's working. Like, something off the shelf is powerful because it just works a little bit, and it's something that the rest of the world's been using too, and at least in the bigger popular models. So you have your dependability there, and if that works, then go with that. If you're aiming for low cost, you might use some different solutions. And if you really go high end, and this is really where we want to be, is to offer people something that can even train on the documents you see, being able to see them, not just train on the text that comes after them. So that's kind of our space of experimentation lately, is and really testing these pipelines so that we can send one to a customer so that you can do it too. Bring in some labels and have it see your documents and really go forward. But you can steer these in really interesting ways too. And so one of the focuses for us has been to take the smaller side of these and get really strong OCR out of it. And so the vision transformer is doing a lot of the work, but you can really get it to do some strong things. Because these are big models in their own right. Like, now it feels like a 0.3 billion parameter model is small, but it's really not. But putting those together, the high end of where OCR is going to go, like, that's really going to change for the first time in quite a while. I mean, the OCR solutions have progressively gotten better with good tricks and things like that, and scaling and stuff. So it's not been stagnant necessarily, but a lot of people would be surprised to know that, because it feels like, oh, it's just OCR, it's not interesting. But our ability to see documents is going to change in a big way with some of these techniques. And sometimes you don't need it. Sometimes you have clean PDFs, and just a basic model will understand it really well. And if you have a common use case, out of the box, they do a really good job. You can fire some things into ChatGPT and just do a really good job. Claude, they know stuff, and so they've seen these documents and they can do a lot of what you wanted. So and then for us also, it's always the typical kind of thing, like productizing that as well. So some people may not know that, or just put it in there, but is that really a production use case where you're not going to sit there and use the front end and put it in? So it's all about APIs and wiring things together and hitting use cases too. So there's the engineering of these is important, and that's a sense too. Maybe is like product design, usability, where we struggle with some of those things. It's interesting to, as data scientists, build a product for data scientists, but honestly, like, a lot of times we want to appeal to people who aren't spending their time coding every day and sitting in the depths of transformers libraries. And so you want to try and make things easy, but then user interfaces matters. So none of that changes really with ChatGPT. And all the similar models. So just trying to figure all these pieces out as we've really seen, like, it's a new world for these products that we have as well. But it's been kind of exciting building on these things and seeing what's possible, and seeing, I think, like, these Kaggle skills too. So the people that are building this, this Kaggle Grandmasters, we have former #1 on this, on this project. And when you see the time to explore and go deep, like, some really cool stuff is coming out. Like, for us, really aiming at the low end and seeing the OCR benchmarks, and really when you see the people that just have, like, that refined competition mindset and just really strong techniques and really a lot of confidence in themselves. I think that's what it's been fun to at H2O work with different people and see those personalities kind of play out. And so the ones that know, okay, we're going to have a month to work on this. I'm going to take my time. I'm going to be scientific about this, and really go for something long. And when you do hit, like, 2 months down the line, it's like, whoa, like that upshot really happened, and that's tough to see. But it just goes back to the same kind of machine learning AI type skills, statistical skills. Going back. So, but that's been exciting to see what's possible on the low end, and we'll just keep seeing all this stuff will for sure get better. People are paying attention. The large language models keep innovating. The multimodal models keep innovating. We'll see more modes. And a lot of times when I'm saying multimodal, I mean vision, but audio, video, all of that's in there as well. Exciting times, I think. So, but we just want to be there to try to, as people, I think you're going to see people doing more things. Like, we've sometimes struggled to even talk to customers to realize they had document AI use cases. So we kind of have years of built up understanding. Like, you're talking with a customer who's already interested in one product, and when they see what you can do, their mind shifts that, oh, you know what, you should talk to these people. These people have it. So there's a lot of people out there that are probably doing these. And this is probably the same as, like, automation from, say, the 90s and 2000s. It's just that a lot of people are not thinking yet. You're just going to sit there and do something. You're going to pay somebody to extract stuff out of these boring documents. And sometimes it's really intensive. If you have a 100-page PDF or something, scanning every single page, trying to look for some specific details. So, that's a perfect use where you just, let's just get the robot to do that. Let's just get an algorithm to do that because they don't get tired. They don't care. Just feed them 100 pages and they're going to do their job. Just the labor of doing that is nice to get away from. And so, but that's probably the case as we were seeing in all sorts of I guess areas of AI or just areas of business, is that when you have these large language models able to do stuff that we almost, it's not we can't think of these, but it's just really, it's different in the last couple of years from where we were. It's going to open up so many use cases that have been there just latent for so long. And then that what that means is you have people that are not used to even thinking about these. Like they're just thinking this. I do tax documents every single day. I don't know what you're talking about. Why do you need test documents and test data and stuff like that? But you want to make the solutions easy for them to use and easy for them to try but also have the accuracy, and be understanding of where it could have pitfalls later. Again, a lot of people are not used to thinking, of the distribution of documents that they'll get in production. They're like, I found a couple examples for you. Let's go look at these, and they found something really easy or really hard. And you just want to think to them like, what's this going to be like moving forward, so that just don't get disappointed whenever you have these out there working in the wild. So,
And from a, if I have to project, let's say, how this will evolve in future, do you expect, let's say, a few really big models which are based on the combination of LLMs and vision transformers to really change the domain, and then maybe we'll start extracting them into smaller models which would probably become more popular, or you expect it to evolve in
yeah,
some.
it's tough. So I think I do. Like we what we see is really like let's say a market for exactly what you described, because that's our focus. And so what was kind of fun as we were playing around with the multimodal training, we're not playing around, but really going after it. But was that when we first checked where we were at by kind of following along with the research literature, produced a good model. And then when you look into the benchmarks, our team was able to find where it was weak in some certain avenues that we hadn't really paid attention to. And it was fun to see. Now the way you solve that is sourcing, generating data to fill that gap. Like, okay, it's weak in this area. We hadn't really seen that math expressions. Okay, we hadn't thought about that, but if that's the way if people are interested in this, we can see that coming a little bit. And there's a lot you can get out of math expressions, handwritten actually, so it helps everything. But it's just a matter of like sourcing that data set, putting it in there, and running the framework again. And that's a really interesting story when you step back and think that like the data set really matters. It all matters, but and that's not super surprising. Yet it still feels like this is. It's interesting to see that you can influence the models in that way. Like you're talking about big data sets, so it's not easy to influence. You're not going to get 10 documents in there, and all of a sudden it'll be very different. But thinking clearly about what you want your model to achieve right now, that's the world. We're still there, especially when you want to distill that to a small model that's more practical. Like our CEO loves to put our Danube models on his phone and go airplane mode. Like that's the level of models, edge devices, phones. There's all sorts of different ways to deploy these. Not everybody wants to put a giant, H100 cluster out there to go do their work. So the small language models trying to hit those use cases, really they haven't seen the entire world. When you're training them, you are training with a lot of documents still, so it's intensive to train them. But I just really like the way that we can see this dynamic aspect of where do we want this thing to focus, and then you can really, they're powerful, so they will learn what you want them to learn. So that's a really cool message, and I think that's the one that I hope for the rest of this year and for a while we'll really explore that and just dig deep into some of these problems where we think that they are weak. So I do, long term, usually that mentality doesn't play out. Usually the bigger models will keep getting bigger, and then you always want to branch off of that rather than have two entirely different products at that point. But I think it'll probably look like half a year at a time, or maybe even longer, of these branches off of like the foundational, the big stuff that's going in there. Figure out how to distill that down. Distilling is an interesting technique. It's getting really, really popular right now. And so yeah, I think that it'll be that, and then it's approachable. So I'm super excited to see like, okay, now that we're at a point where we've done something very compelling in the multimodal space, and it just feels like, man, we can take this further, because a lot of the research world in the multimodals is looking at kind of like customer, like more consumer type stuff. Like I'm taking pictures with my camera, and you want it to be smart about it, understand that. And so what we like, our focus of enterprise customers is they're usually dealing with thousands, millions of documents, and just different use cases of different mediums. But it's a different mentality. And so that the document focus, like for us to really dig in, is exactly that. Like, how can we use our experience with this of different data sets and really push in and get the right, get our training data in there where we have representative extractions coming out of it and things that people want to do that we've learned over time. So yeah, I think you'll find this kind of a cycle a little bit where the base technology will keep improving, and you'll want to branch off of that, take the best techniques, and then go create something that works in a small space that's maybe aimed a little more specifically at a problem. And so, like a custom OCR model, custom for us to certain detection models, just able to do different things, and they do it out of the box. That's what you really want. Like, they're just smart, zero shot, like they know stuff, and then maybe also capable of fine tuning more easily, or prompt tuning any of the techniques that will be out there. So that's where we see. And I do think that'll be the case for a little while. I mean, everyone will get to know like the top 10, 20, depending on where you're at, 30, 40 models that are out there, and that'll keep being the case. We'll all still keep, see what's powerful. And obviously you also see a mix of using the big models to help you train the lower models, and this is the case, like of getting your annotations. If you're going to train something, whether you're fine tuning from something else, or you're training, say, more a foundational type, like what we're doing a little bit, then there's a lot of synthetic data out there, and so like kind of having that everything kind of harmonizes a little bit. So you're using the big models as those keep getting better and better, and more cost effective too. So you can we'll keep being able to do more stuff with those, but you want to pay attention to where the latest research is and figure out how that branches off and gets you to something a little more enterprise ready, perhaps sometimes. But it's a mix too, and so it's easy to just use the big LLMs. There's nothing really wrong with that, but some use cases, it'll always be, there's slight refinements, and we find different environments like air gap type installations. There's a lot of people who can't use, like, there's different environments when you get and see the different difficulties that people may have using Gen AI in certain ways. It's just like people are all struggling with every organization has their own kind of policies on when you can use it, when you can't, approvals that you need to get, and all that kind of stuff. So, so everyone kind of has a different answer for how they solve this sort of thing. So having more and more tools available for wherever you sit is how this is going to go too.
And that almost feels like a perfect use case for a agentic solution. So depending on where the problems are, you would have one agent acting. So do you see that playing out, and these
Absolutely.
solutions evolving into the agentic interface, and then that kind of
Yep.
adopts itself to the customers' need, and then a lot of what we are right now probably engineering to make the solution work. Agents kind of take care of that to get to a good solution.
Yeah, definitely. And I think that's looked a little more like reality in the last year than like maybe a lot of people went there quickly, because it's natural, either a strict agent by the book or just like workflows that include like cycles essentially. And so, but now, but it's tough. Like a lot of the early ones, people were promising this hope, but it was really refined to just the specific use or something like that. But as the models get stronger and bigger, I think it's probably like a combination of lots of thresholds that we're starting to cross in certain ways. So you can unlock certain problems if the large language model is above this level, and we're starting to get there now. So yeah, that's certainly an interesting one, because it's very natural to want to do these sorts of things, to use a few different ways to solve a problem, almost like the way humans do, which sometimes it's just straight away, but sometimes you're kind of moving through the problem a little bit at a time and checking yourself or looking at it. It looks right to me. And these are not, you don't always get that out of the box when you just try one shot, but we're seeing absolutely everyone's kind of embracing now, like mature chain of thought type ways of going through the workflow or agents. But yeah, we see that. So internally, H2O, that's definitely like ideas on our drawing board, that we will be trying out now that we are working the multimodal. Now, what can we do with it? Now let's use that in agent flows, and together, with multiple models maybe to help steer it. So we're certainly seeing still for general purpose, like agent use cases, you still need some really big models. Like we're using, the closed source to open source, the 400 model, a billion parameter llama model. That's a big model, tough to run, but But when you do that, that's one of those thresholds, really. Like if you sometimes for a lot of these flows, if you start using something inferior, it just like never gets off the ground, failure to launch kind of thing. So and there's just ways of going about it, use case for use case. Like maybe that works to use a small model if you can just think about it and you're kind of putting your head more in it. It's more a little more programmed and steered. But as the models get more competent, then yeah, we can start to be more generalized with our agent flows and things like that. And Document AI has a lot of these type things out there. There's a lot of people that want to go and extract things, but as you get through it, you realize certain things like validating parameters. Like, well, okay, now that you got that, all the totals line up, or certain things where it's really just it's a collection of things working together. Maybe it's a strict agent, maybe it's just really a workflow. But yeah, that's going to be a big deal. And it feels like if you said agents like 12 months ago, it's more of like, well, people are almost like, I don't know. It seems like almost overhyped. And it's hard to say that because normal overhype would be like 3 years and nobody's getting anything out of it. Now it's like 6, 9 months and people haven't seen it just yet, sort of thing. But so yeah, agents will be certainly really exciting to see how we solve problems just collectively. And it's probably just going to blow out certain problems that were handled a certain way. You just don't need to do that anymore. Yeah, but with that, like you say, it's always a spectrum of options. There's like, if you want to pay for, Claude 3.5 on all of your problems, and you're just going to send like mountains of data in, it's costly. It's costly to pay for some of these. And the same on the open source side, hosting a 400 billion model. You need some pretty big hardware to do that. So, but all these things get better. Quantization that happened, like even early on, it's just amazing to see some, like people are out there with 3-bit models and stuff like that. But all of a sudden, then you can fit it on commodity hardware, and you can really use some larger models. So the innovation is just really exciting at this point to see. And that means, whatever you think you may not be able to do, and, right now, or you're struggling because you think you should be able to do it, just wait, maybe in a year or two, we're going to be there. So really exciting times to see that everything is moving to the right, up and to the right. Like we're moving that way. It's getting stronger, bigger. And then you figure out ways to make big smaller, and then they'll make bigger again. And, that's the way it's going to go. So.
Yeah. And the work which you and team are doing on, the multimodal models and then kind of the combination. Can you explain that in a bit more detail? And then what are the use cases which that enables versus some of the previous models?
Yeah, sure. So for us, we I guess it really emerges to me like there were a few of our internal benchmarks where a donut model picks destruct the type that could see the vision layer.
Mhm.
We're unbeatable really compared to the older techniques that we had. And so that was always interesting. And we've had customers again, like I was saying, like asking for unlocking the OCR and making it dynamic, and that they could control it without fully retraining. I mean, you can retrain OCR, but it's intensive. It's very difficult to do that. And it's difficult to drag enough data to get that to work for a specific use case. So with the multimodals, that these vision transformers really strong, that natural progression from what we saw with Donut and Pix Destruct. And so for us, it just felt like that's going to be the way forward. It's not new. It took us a little while, almost in a certain way, to try it. When we did try to just okay, let's get into this, and let's see. Our CEO said let's walk through that door and see what's on the other side. We can all read the research and see what it's like. And so that was a cool way of saying. So we experimented with Tiny Lava, which was a cool library that was out. The principle, same with the small language models, and the premise of the paper was just that being sharp about these and looking at the latest techniques. We can get the size down. You can achieve more if you're careful and using the latest and greatest techniques with a small model than you can for a much larger, like 1 billion scale versus 30 billion. And you see this now with the multimodal. It's still the case even now. That so if you really focus at doing a good job with some of these strong vision transformers, you can put a small model and a small vision transformer together and get a really, really strong result. And so that was kind of cool. Our team went through that and went through the papers of Tiny Lava, and you didn't need huge GPUs to do that. And just kind of executed that, followed along with what they were saying, plugging in our own framework. So we just always wanted to kind of make it H2O. So we were trying with our Danube family of foundational models, and immediately we saw the same results. like when we put it there, we were on par and better with some huge models at that point. And so then the next step, so seeing it, but with our focus specifically, the vision transformers at the low end of the scale are looking at a fixed image, usually 300 or 400 pixels. And if you think of a document, like a lot of us take, if you were to take a regular image out of a document, you might be seeing something that's 3,000 pixels wide by 2,000, maybe even bigger, but certainly 1,000 or more to really zoom in to see the text. And it's just natural for us, natural for PDFs, natural for OCR, but it wasn't natural for the vision transformers up front. So, but those techniques started to, like, there's a lot of innovation with how people patch the images. And just the cool thing is, like, the innovation's out there, open source, like some really cool, just it's really changing. Like every month you see new stuff, new ways of doing this dynamic patching that's currently out there, of taking, like, zooming in a little bit, let's say, to that. But it was the same, it's kind of same technique. So it's approachable. It's maybe not it's tough to do, like if you're just sitting there on your laptop. So you do need some GPUs to do these, but we're not, again, talking about, you don't need to work for Meta to get thousands of GPUs to be able to do this stuff. So that's kind of fun too, is to get these. And fortunately for a multimodal, it trains a little shorter. So our Danube family models, those took about 40 days ish to train, and so that's kind of budget for a lot of companies. Like, you can do that. You can have your own LLM if you do that. But the foundational model, again, 40-ish days, versus the multimodals are roughly 4 on the same axis, I guess you could say. So looking at the same compute, so about 10% or so of what it takes. And even if you get smaller on the 0.5B that we're doing. So it's kind of approachable, that you can take these and get a really strong result. And you can see, so following a lot of the literature is leading the way here too. So you see people are really forthcoming with what's out there, the data sets, a lot of public data sets. And then, like I said, with our side, so once you see those public data sets, so the interesting path for us was to follow along with what it is, see how that worked well, and see how you can get better. And then it was just look into what can we do to help this get along. And there's a little bit of tuning. We were trying our tuning options, like a typical deep learning type um, exploration, experimentation, but really the data sets. How can we grab data sets, and how can we be clever and creative about getting data sets we have? And so your data sets for all this Gen AI world is either text, or in our multimodal world, it can be text input and an image input, and then the output is text. And so it's a conversation, or it's like a caption or something. And so just when our paper that will be out is just, like, one of the cool visuals is to see some examples of the data sets we pulled in, and what does this look like. And so sometimes you are seeing a picture of a chair and saying, describe it, and it's saying, okay, it's a white chair that has 4 legs and it's sitting next to a door, something like that, just describing what you see. And other times it's more applied, like trying to do the stuff that we are doing. And so here's an invoice, and extracting key value pairs out of it, just to teach it generic, like, this is how we're getting information out of it. And just, there's a wide spectrum of that. But it's easy, not easy necessarily, but approachable to source the data and think your way through it. And so when you see that, okay, it's weak in this area, how can we gather data that teaches this principle, we think? And so it's problem solving is the appealing part to me, is where we're at right now. And so that's kind of cool. And again, I feel like approachable. And so and what we're doing here is we're usually taking the same base data set and then adding stuff. Usually it's just adding. We don't really need to swap. There's so much of it. But sometimes I think with customers, what we want to be ready for is that they're going to bring in a certain data set. And so, rather than just fine tuning on that data set, probably using some of the data that's already out there from the training flow. So it all kind of, what's nice is that it feels like all the work you put in on the journey keeps being useful as you get your full solution. So it's been kind of fun to watch the team. I'm not going to pretend that I'm doing much of it. I'm kind of like watching the results and kind of steering them. We should be able to do this and following along the results. But we have some awesome people that are participating with actually getting this through. So Wancho, Shaikat, Chen are doing some awesome stuff with the multimodal work there. And so it's been fun. And I think, really, so we can go back to the start. Like, if it's a listener kind of like getting involved with this, or you feel like you want to kind of understand this world, the tiny lava paper, like, is a kind of cool way to start, to just feel like what this is like, looking at some of the data sets, read along with their paper. Like, we're still with that world. Like, the papers are approachable, and you can really see what they're doing with how these are working, and then kind of think, would this work for my use case? If you're vision rich, so if there's a real visual aspect of what you're doing. So I think that's what yeah, it's been an exciting journey, I would say. But even that first step was kind of cool to just go and do it. Like it's a little harder to go and do it from the with the training side than it was, because the flip side of it's easy. It's been easier than ever to just go and do it with just trying these LMs. Trying, it's all you can get on Hugging Face spaces to do these multimodals. Like this started kind of for me with Lava, Cog VLM, we're out there, and now that space is kind of blown up. So there's a lot of cool stuff out there. Just go and try it. Upload your image, see if it works for you. And if it isn't, then yeah, this is an approachable way to try to customize it for your use case.
And is there a way to experience these models? Are they available on H2O site? So if someone wants to play
Yeah,
around and
absolutely.
make,
So, yep. So our Mississippi family of models are on our Hugging Face space, and the same as our Danube models. So you look at our collections out there. We got a collection for Mississippi, and we'll keep innovating these as well as we figure out different ways or just like improve some of the techniques. There's always a few things you wish you did, but you.
yeah.
So and then yeah, we have some Hugging Face spaces to demonstrate how to use it, and also look at some of the benchmarks. And so showing people, especially because I guess like maybe I've been kind of implicitly saying this, but almost explicitly, when you look like and see that like a multimodal is trying, you're asking it to do a lot of different things. And so like if your use case depends on this certain aspect or this aspect, then maybe one of the open source multimodals are someone else's will be a better fit for you. And so the benchmark, the benchmarks that are varying out there, looking and seeing which one matters, because they're not as standard. I would say they're not as standard as the LLM benchmarks, where we've always been using a multitude of benchmarks in the LLM world. With the multimodal, there's even a slightly wider range of what you'd want to focus on. And so that's one of the things we've got out there as well, because that's what we've been paying attention to as we've been doing this. And so how well is it working in this space? And let's try to correct that and just like get each little part aspect of this as optimized as we can. And so, yeah, get out there and try it. You can download it, go use it. You can go see it on our space and just go try some things out and see if it works for you. And if it doesn't, there's some bigger ones out there. We'll always get ours better, things like that too. So.
Yeah, I think there was so much to catch up on. We are well above time.
Yeah,
So
it's fun. Yeah, I love my job. Like there's a lot of it's been fun to be in AI. So yeah, it just
yeah,
feels like it's fun to talk about. I've always been that way with conferences. Just chatting with people afterwards feels like I can talk for like 10 hours on this kind of stuff. It's fun. So.
that is so true. But towards the end of each of these podcasts, we ask a few rapid fire questions to the guests, and I'll try and cover a few more things there.
Sure.
Uh, so, one use case which you are most excited about to solve with AI.
I guess it maybe because I've had my head in the enterprise space so much. So I mean, I am surprised. I'm excited with how GenAI steers what I've been doing. So so doing these unlocking documents in different processes, and we just see it with customers. They haven't think to try something, and sometimes a simple solution will work. So for me, it feels like just seeing this next evolution of the automation of when software became popular and automating so much work for people 30 years ago. Like we're now at a different element where we can really automate a lot of that. It's always been a spectrum. We've always been able to do that, but I think these things that like now, if you think about it a different way, as we see agents, these models get stronger in so many different dimensions, we're just going to start seeing a lot of that work go away and be automated, and it's going to work. Like, whereas like it's been a struggle, it feels like sometimes to try to be on the leading edge of NLP and image, where sometimes the use cases don't work out. But now I hope our success rate gets higher now, especially with higher ability to experiment with all this. So
And
got to be rapid here.
how much of code which you write today is written by LLMs for you?
Oh, that's a good one. Yeah, because actually, truth be told, I'm an R data table programmer, and I've actually been surprisingly slow to pick on Python. I mean, obviously, I've been using Python because you have to for deep learning and all that, but I'm a pretty bad Python programmer. So quite a lot is actually the answer for that. So, just pandas, NumPy stuff I like struggle with sometimes, certain things. So I've actually used ChatGPT quite a lot to help me along with that. I always try myself and send the errors. That's my way. I'm not using like Copilot or something like that. I'm more like, let me go out myself or I won't learn it. But quite a lot, actually. Quite a lot of code that I've written, especially if it's written in Python. It had an AI hand in it all the time. So
Yeah. And any particular book or podcast which you really would recommend and which you go back to?
I think there's a lot. Like, I think it's just different people for different types for different people. So, like the one I approached really like ages ago that really is a huge bit of who I am today is why I do this. Was just really fundamental. So it's an old Stanford course, but I just feel like really it is. It's find the one that works for you because everyone loved Andrew Ng's, but
Yeah,
I saw that the funny part is like you're going to want to work this out yourself. I was like, no, I'm not. I don't want to do that math. I don't want to do that calculus. My intuition's good enough and where it's weak. So, that one just didn't appeal to me. So I think it's just for everybody kind of finding the one that resonates with you and then going. And I just taking it up. So it's really usually simpler ones, even like the basics of a Josh Stormer sort of thing. Like even with me, like, okay, what are we doing here? Like I know all these techniques. I'm in it day to day, but I'm a little further away than I used to be for some of these. So you want to kind of keep grounded. So yeah, that's it for me. So
yeah,
yeah.
no thanks. In fact, we had Josh at Data Hack Summit this year.
I noticed that. That's what. Yes, I saw that, and my kids thought it was hilarious that I was watching YouTube videos while working out, reminding myself of how we got to certain spots. So I've actually watched quite a few of his. I even
Yeah,
donated. So
great. Yeah.
yeah,
Great. Thanks a lot, Mark, for sharing these insights. And then, yeah, there's so much to catch up on, and then it feels great to connect and speak to you about all this,
yeah.
which
Yeah, it's
you're.
been really fun. I would just say if you're listening to this and you're not one of the types that's just going and doing it, just go get out there. That's what the competitions are. LLMs are easier than ever. So just go and do it. Don't get stuck in your own thoughts. Like just get out there and go do it. So yeah, it's fun times, fun times. Thanks for having me. So and yeah, like you said, we it's been almost pushing 10 years since we started collaborating, and those were fun. We didn't really talk about that much, but yeah, that was a fun time when you guys saved us big time. So yeah, very appreciative of Analytics Vidya. And fun to do the hackathons after that. And yeah, thanks for having me. So.
Thanks a lot, Mark. Thank you.